Hello there, welcome back again to today's video tutorial, which is literally more like a part 2 of what we had started in our previous video, where we were looking at the Japanese method of multiplication, or rather the Japanese multiplication strategy. In this video, we are going to continue with this method. However, we are going to be multiplying 3-digit numbers by 2-digit numbers and 3-digit numbers by 3-digit numbers. You would not want to miss this one. Stick around and let's solve mathematics together. Multiplying numbers using the Japanese multiplication strategy is very interesting in that the numbers which we are given are replaced with lines like you saw in our first video. I won't go much into details explaining this because we did already explain in our part 1 of this video. Let's straight away go and begin looking at a few examples that we are going to solve right in this tutorial. We are going to look at 4 different questions, and I would want you to follow through because all these questions we'll look at will have an increasing intensity. So we'll start from the easy one and we'll end with even those ones which are a little bit hard, looking at the 3 by 3 multiplication using the Japanese strategy. So question number 1, as we can see right there on our screen, says calculate 135 times 21. Calculate 135 times 21. All right, as usual, we said that this strategy, one of the things that it uses is that it replaces the numbers we are given for lines. So let's begin. So we have the number 135 times 21. So let's begin doing those replacement. So that one will be represented by this line here. So this line represents that one. We'll leave a gap midway there, and I'll create 3 lines for that. 1, 2, 3. All right, then I'll leave a gap midway there, and I'll create 5 more lines to represent the 5. 1, 2, 3, 4, 5. So 1 line representing that 1, 1, 2, 3 lines representing that 3, 1, 2, 3, 4, 5 representing that 5. Okay, we go to we have our multiplication sign. Now we go to that one. So the 2 is going to be represented in that way, 2 lines in that way, 1, 2, and that one shall be represented by that 1 line there. So that is what we have. That is what we have. So let's divide this pattern which we have into 3 segments like we did. So the first one is going to be this one. Our second segment is going to be that one. Our third segment is going to be that one, and our fourth segment is going to be that one in that way. All right, so this represents the ones, this represents the tens, this represents the hundreds, and this represents the thousands. Okay. All right, so now let's begin to count starting from the right on the ones section or the ones place value. You have 1, 2, 3, 4, 5. We got the tens place value. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 there. We have 13. Now we know that the tens place value cannot have 13 as it is. So what we're going to do is, since it is 13, we are going to remain with the last digit, which is a 3. All right, which is a 3, and we'll carry this one to the next segment there. So we'll leave a 1, then we'll say plus whatever we're going to count in that region. So what do we have in this region? 1, 2, 3, 4, 5, 6, 7. So 7 plus 1 gives us 8. So under this region, we say we have 8 plus the one which has been carried from the tens place value. And then the thousands area, we have 1, 2. So we have 2. So what numbers are we looking at? We are looking at 2, 8, 3, 5. So when we say 135, when we say 135 times 21 is equal to 2, 8, 3, 5. 2,835 as our answer. Okay, having done that, we go to our second question. And our second question says, calculate 321 times 23. Calculate 321 times 23. So 321 times 23, just like we did in the previous, we're going to start by replacing the numbers with lines. So we have 3 there, which means we are expected to do 3 lines. Let's go. 1, 2, 3. We'll leave a gap midway, and we are going to do 2 more lines. 1, 2, and we need 1 more line now. So leave a gap, and we do 1 more line in that way. So 1, 2, 3 represents that 3. 1, 2 represents that 2. 1 represents that 1 times 2. Times 2. So we indicate 2 lines. 1, 2, and 3 there. We're going to show it with 3 lines. We're going to show it with 3 lines. 1, 2, 3. All right, so 1, 2 represents that 2. 1, 2, 3 represents that 3. I hope you are following. Okay, so let's segment, or maybe put this pattern of ours into different segments or sections. We have the first one over there. We have the second one. Okay, pardon me, it's supposed to come like this over there. Then we have the third one over there, and we finally have the last one over there. So remember, these are the ones, these are the tens, these are the hundreds, and these are the thousands. So these are literally the placeholders for these numbers, just so that we know where we are. All right, so let's begin to calculate the line crosses, or rather the line intersections, starting from the right on the ones place value. We have 1, 2, 3. So we have 3. We come to the tens place value. We count 1, 2, 3, 4, 5, 6, 7, 8. So you have 8 there. We come to the hundreds place value. Let's count the line crossing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 over there, but as it is, we can't write 13. So we keep the last digit, which is a 3, and then we carry the 1 to the other section. So we have 1 plus. So that 1 is a remainder we've gotten from the hundreds place value. It was a 13, we remain with a 3 under the hundreds. So we've carried the 1 to the thousand section. And so 1, we are adding it to whatever we're going to find under the hundred section. So you have 1, or maybe let's not count it for now. Let's remember it at the end. Let us count the line crossings here. We have 1, 2, 3, 4, 5, 6. So you have a 6 there. So 1 plus 6, it's equal to 7. So under the hundreds, we have a 7. Under the thousands, we have a 7. Under the hundreds, we have a 3. Under the tens, we have 8. Under the ones, we have a 3. So 321 times 23 is equal to 7,383. If you've done that, then you've been able to solve it. You have to congratulate yourself. Quickly, let's move to our third question. Okay, so now we have our third question, which says calculate 347 times 215. Calculate 347 times 215. Okay, now the heat levels are going up. In our previous two questions, we're looking at the 3 by 2 digit kind of multiplication, but now our third question is literally a 3 digit by 3 digit kind of multiplication, which means that even the solution that we are going to have will be seemingly a little bit more complicated than what we've seen in our previous question. So I would like it if you would really keenly follow through, so that you don't get left behind on this one. So as we have always been doing, let's be able to represent those numbers with lines. So 1, 2, 3 lines, they are representing that 3. 1, 2, 3, 4. 1, 2, 3, 4, representing that 4. And last, let's do the 7. Let's represent the 7. So 1, 2, 3, 4, 5, 6, 7. All right. So 1, 2, 3 for that 3. 1, 2, 3, 4 for that 4. 1, 2, 3, 4, 5, 6, 7 for that 7. All right. Let's now move on to the 215. Let's show it also. Let's represent it with lines. So to do that, as usual, let's draw 2 lines. 1, 2. So 1, 2 represents that 2. We'll put 1 line there. 1. This 1 line represents that 1 there. And now we'll have to put 5 lines this side. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 lines represents that 5 right over there. So both the numbers that we are considering for multiplication have all been represented with lines. So let's go ahead and begin the actual calculations here. So remember, we first begin by segmenting our pattern like we always do. So firstly, we have that segment there. Secondly, we have that one there. Thirdly, we have this one in that way. Fourthly, we'll have that one. And fifth, we'll have that segment there. So this one represents the ones, this one represents the tens, this one represents the hundreds, this one represents the thousands, and this one represents 10,000s. Okay, so there we have it now. Let's begin our multiplication, our calculation. Let's count the line intersections or the line crossings in each segment, starting from the ones to the tens to the hundreds to the thousands and then to the tens of thousands. So let's begin. Make sure you don't miss out any line crossing. If you do, your answer is likely to be wrong. So you really have to make sure that every line intersection has been counted. Let's begin. 1, 2. So you can count with me so that we can both keep track. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. So under the one section, we are looking at a total of 35 line crossings. 35 line crossings. So yes, as we do, ones cannot have a 35 in that order. So what we are going to do is, for that one, we are going to remain with the last digit, which is a 5. And then we are going to carry our 3 to the next segment in that way. So whatever we are going to find in this segment is going to be plus 3, the 3 which we have carried from the ones segment. However, we are going to add the 3 after we have calculated the line crossings which are under the tens segment. Let's begin to calculate the line crossings or the line intersections. Count with me. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So we say plus 27 in that way, and our answer becomes 30. Our answer becomes 30. So though our answer is 30, what we do is we cannot remain with a 30 under the tens segment. So what we do is, since it's a 30, we are going to remain with a 0 and we are going to carry a 3. So this 3 in front here, we're going to carry it to the next segment. So we are going to put a 3 there waiting to be added onto whatever we are going to calculate under the hundreds section, waiting for whatever we're going to find under the one section after we have calculated all the line crossings. So let's count together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. So we have a 33 right there. So what we are saying is 3 plus 33, which gives us a 36. It gives us a 36. So as usual, we remain with the last digit being a 6. So we remain with our last digit there being a 6, and we are going to carry the 3 as as we're going to carry a 3 to the next segment, so we're going to indicate a 3 there, plus, so like we have explained earlier, like I explained earlier, this 3 that we have carried is going to be added on to whatever we are going to find together under the thousands section. So that 3 is waiting to be added onto whatever we're going to find after adding all the intersections in the hundred section. Let's begin to add or count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 line crossings. We have 11 line crossings. So 3 plus 11, we are looking at a 14. And so we cannot remain with a 14. We cannot remain with a 14. So what do we do? Now that we can't remain with a 14, as we have been doing, we remain with the last digit being a 4, and we carry the 1 to the next segment. In this particular case, the next segment is the 10,000 segment. So we have a 1 waiting to be added there to whatever we're going to calculate under the 10,000 segment. So let's count the intersections in here. 1, 2, 3, 4, 5, 6. So looking at plus 6, which is equal to give us 7. All right. So we are done. We are finished. Let's quickly take a look at whatever values that we've been able to acquire in every segment. So when you look at the 10,000 segment, we have a 7. When you look at the 1,000 segment, we have a 4. When we look at the 100 segment, we have a 6. When we look at the 10 segment, we have a 0. And when we look at the 1 segment, we have a 5. So what then is our answer? Our answer is equal to 74605. So in short, 347 times 215, it gives us the answer being 74,605. 74,605, and that is our answer. I truly hope you were able to follow through to the latter. All right, let's go to our fourth and final question, and then we'll conclude our video tutorial. Our fourth and final question is asking us to be able to calculate 517 multiplied by 174. 517 multiplied by 174. 2, 3, 4, 5. So these 5 lines represent that 5. One. That 1 line represents that 1. We do 7 lines this time. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. That 5. 1. That 1. 1, 2, 3, 4, 5, 6, 7. We have that 7 over there. We now multiply with 174. So for 174, let's begin to do the lines as well on the other side. 1. So that 1 line represents the 1. Next, we're looking at 7 lines. 7 lines. 7 lines. 1, 2, 3, 4, 5, 6, 7. Let's counter check. 1, 2, 3, 4, 5, 6, 7. Good. We go to our final linings. We are looking at a 4. A 4. 4 is the last one. 1, 2, 3, 4. We are good to go with our pattern. Let's divide this pattern into segments like we've always been doing. 1, 2, 3, 4, 5. All right, those are our segments that we've already done, or others would call them the regions. Okay. All right, so now let's name them. The first one, we have the ones, we have the tens, we have the hundreds, we have the thousands, and we have the 10,000s. 10,000s. All right. Okay, so let's begin to count the line intersections, beginning with the lines in the first segment for the ones. Let's count together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So we have 28 as our initial answer there, 28. So since we have 28 as our initial answer, we cannot have 28 under the one section. So what do? We remain with the last digit being an 8, and then we carry the 2 to the next segment in that order. So we have a 2 plus whatever we're going to find under the tens segment. Let's begin to count the line crossings which are under the tens segment. So we begin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53. So we have 53 there. So 2 plus 53 is giving us 55. As always, we cannot have a 55. We just need to remain with a one digit number. So since it's a 55, we remain with the last digit being a 5, and we carry the other 5 to the next segment. So we say 5 plus whatever we're going to find under the hundreds segment. Let's quickly begin to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. So we have a 34 right there, and we are looking at a 39 as our final answer. So we have our 39 there as our final answer. Like we've done in our previous segments, we said we can't have a two-digit number like that. Therefore, we are going to choose to remain with the last digit number being a 9, and we're going to carry a 3 to the next segment So that's the 3 we've put there, plus whatever we're going to count under the thousands segment. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So we have a 36 after having added all the line crossings under the thousands segment. So we have a 36. So we say 36. So since we have a 36, 3 plus 36, it gives us 39 again. So we can't have a 39 like we do now. So we get the last digit there is what we remain with, and we carry the 3 to the next segment. So there is a 3 which we've just carried from the thousand segment. So let's count whatever we have in under the 10,000 segment, and we will be able to add it to the 3 which we have carried from the thousands. Let's count the intersections. Let's count the intersections or the line crossings which we have. All right, so we have 1, 2, 3, 4, 5. So we have a 5 in that way. We have a 5 in that way. So 3 plus 5 is equal to 8. 3 plus 5 is equal to 8. Having found our 8, and this was literally the last segment we have, let's counter check all the values that we have under all the segments. So the 10,000 segment has 8, the 1,000 segment has 9, the 100 segment has 9, the 10s segment has 5, and the ones segment has 8. So 517 times 174, it gives us 89958. So what we are saying, that 517 multiplied by 174 is equal to 89,958. That is our answer. If you try to counter check this answer with a calculator or any other known method, you are going to find the same answer. So that was it, looking at the Japanese multiplication strategy part 2, where we have been focusing on multiplying 3-digit numbers by 2-digit numbers, and also multiplying 3-digit numbers by 3-digit numbers. I hope you liked this video. For more of such videos, please leave a comment under the comment section. Remember to like, to subscribe, and also to share to others so that they too may be able to take part in whatsoever we are doing together.